you. These are just functions, right? They've been given the name f of x. They've been given the name g of x, just so that you can tell them apart. So in part A, f of 8, you just go to the f function and plug in 8, right? On the right-hand side, because the left-hand side is just y equals. So all you have to do for part A is 2 times 8 plus 9, and you'll have your evaluated answer. So 16 plus 9 is 25. So you ended with a number. You plugged in a number for x. You basically generated the output, the y value. So 8, 25 would lie on this line. So f of 2, you're going to plug in 2. So 2 times 2 is 4 plus 9 would just give you 13, right? You had an input, plugged it in, generated the output, the y value. So g of 7, that just says, hey, now you're going to use the g function. You're going to plug in 7 and see what you get. 7 minus 8 is -1. So you've done that before. That's just evaluating functions. So when you look down at D and E, you don't have a number to plug in anymore. They want you to take, so do you see how the g function is inside f of x? So they want you to take the entire g function and plug it in for the variable in the f function. So you're going to leave the rest of the function intact. I've got a 2, I've got a 9. Those don't go away. So I'm going to do 2 times x minus 8. That's replacing that x altogether. And then I'm going to add 9. So I couldn't plug in a number, so I plugged in the entire function. And now I'm just going to simplify. If you put in a function, you're going to end with a function instead of a number. So you're just going to use the distributive property. 2x minus 16 plus 9 would simplify to what? 2x minus 7. So we composed the two functions. I could have written it fog, f of g of x. I wrote it this way with the parentheses, but f of g is what I just did. The one that comes second is the one that's inside the function. So now we're going to do it in the reverse order. So now f is on the inside. So you're going to take this 2x plus 9 and plug it into this function only for the x. So you're going to take 2x plus 9 and just subtract 8. 2x plus 9, that's basically your x minus 8. The parentheses aren't really doing anything, so I can just do 9 minus 8 and get 1. Are you kind of with me? Does that ring a bell? So algebra 2, people, I don't think we did this at Kennett. Maybe you've seen it before. Okay, so that's composition. You ended up with 2 different equations, so doing it in one order doesn't always get you the same answer as doing it in the reverse order. But we're going to see something interesting happen with inverse functions. So why don't you try A, B, and C, see what you get when you evaluate these new functions, and then maybe we can practice the composition together. So plug in f of 8, g of 8, and g of 0, and see what you get. Finished, you can look up and we can see if we got the same answers. So that's evaluating. I think the only mistake students make with that is they think they have to do something on the left side of the equation, but these are all just y equals, y equals, y equals. You only do stuff on the right side where the x variable is. All right, so let's see. I have to plug g, which is 2x plus 16, in for x in the first equation. So I'll still have the 1/2, open up parentheses. Where that x is, I'm going to replace it with 2x plus 16. And then outside the parentheses, I still need to subtract 8. So something special happens on this one. When you distribute the 1/2, you get x plus 8 from this parentheses, and then you're subtracting 8. So you end up with x as your output. We're going to learn that this is an inverse function because everything in one function undid everything in the other function, right? The 1/2 undid multiplying by 2, and then kind of the adding 8 and subtracting 8 undid each other. So if we do it in the other direction, now I'm going to take this function. So the 1/2 x minus 8 is going to get plugged in where the x is in the second function. So I've got 2. And then where the x is, I'm plugging in 1/2 x minus 8. And then I still have to do the last part, adding 16 at the end. So guess what? It undoes everything again, because from the parentheses, when you distribute the 2, you get x minus 16, and then you're adding 16. So you have to check for an inverse in both directions, but if everything cancels and all you're left with is x, these are actually called inverse functions. So we're going to learn about inverse functions tomorrow, unless we start it today, but so they undo everything about the other function. So I'd like you to try a couple other functions down below. See if you can try composing and evaluating on 3 and 4. And then we're going to kind of do an intro to logs before you do some more guided practice. So let's see if I can walk around and help you and try to do 3 and 4. All right, I'm going over this. So let's see. -2, make sure that -2 times -2, because when you plug in -2, you're squaring the number -2 times itself. You get +4, right? No solution, can't take the square root of a negative number. Don't write 0 though, because to me 0 is a number. Either write no solution, undefined, and then these both cancel out, right? The square root, if you square it, then you're back to x, and if you square root x squared, you're back to x. So those are actually inverse functions, and we actually knew that those were undoing of each other, right? In a problem, if you're trying to solve for x squared, you take the square root of both sides. So we should recognize that those are inverse functions anyway. And then down at the bottom, I got 24 and then I got 0. And then these also turned out to be inverse functions, didn't they? The 1/2 and the 2 kind of undid each other. And then kind of this +8 and -4, when you compose them, end up adding up to 0 after you distribute. So that's composition. We're going to use composition to test if something is an inverse. So that's really why you need to know composition, is to use it when we're looking at inverse functions tomorrow. All right, so that's kind of planting the seed of composition. And I've got a practice sheet I'm going to have you do kind of after this. So here is introducing you to logs that just use mental math. So we're going to go into depth on logs on Friday, but this is just starting to just realize a log and an exponent are just a way of expressing a power of a number. So if you've never seen logs before, that's fine. You can just catch on. You'll catch on pretty quickly here. So what does this log equal? So the base of the log is actually the base of an exponential problem. So 5 raised to what power will give me 25. What power is that? The second power. So the log is equal to 2 because 5 squared is 25. So you're trying to get to that big number, like the log of the big number is 6. How can I go from the base of 6 to the number 6? So if you're trying to evaluate a log, I always just kind of write it out for myself, or I'm thinking this in my head. 6 raised to what power will give me back 6? So the answer is 1, right? All right, what about number 3? 7 to what power would give me 49? 2, right? So see how these are all power family problems? I want you to look at number 18. How do I go from 2 raise it to some power, and get to 1/2. How are 2 and 1/2 related? So 2 to what power is 1/2? It would be the negative first power, right? Okay, the other one I wanted to point out is number 17 before you try some of these on your own. If there's no base, the base of a log is 10. So logs are based on power of tens. So it's just like a square root symbol, right? If I just told you the square root of 25, you know that the index is 2. We don't write a 2 there usually. So right here, I'm just telling you, the base is 10. 10 to what power would give you 1,000? The answer is 3, because 10 cubed is 1,000. So kind of take a minute, see which of these you know the powers to and which one of these maybe are a little bit harder, and we'll go through them in a minute. But these are really just mental math, evaluating powers of the base. Powers should start to be kind of mental math for you. Let's see, number 4, 3 cubed is 27. 8 squared is 64. 11 to the first is 11. 2 to the fifth is 32. Maybe you're starting to know that power of 2. We don't use it often. This would be a reciprocal, so the negative first power. 9 squared is 81. 8 to the 0 power is 1. So remember I said you're going to keep seeing that anything to the 0 power is 1. So there's another example of when we needed it to solve a log. Number 8, 2 cubed is 8. 4 squared is 16. 10 squared is 100. 5 cubed is 125. 2 to the fourth on this one is 16. 3 squared is 9. We did 17 and 18. And then 19, I have to flip it and square it, right? So negative 2. And then 5 to the 0 power is 1. So I did leave off like a fractional exponent type answer, but if you had log base 64 of 8, what would the answer be? How do I go from 64, raise it to a power, and get 8? That would be that 1/2 fractional exponent, right? Because 64 to the 1/2 power is how you would get to 8, take the square root of 64. Question?